We spend so much time debating which AI model is currently on top, but asking what's the best AI model right now is actually the wrong question. In a world where benchmarks change every week, the real value isn't in the raw power of the engine, it's in how that power is applied to help you think, learn, and create. Don't be misled by the illusion of the 90% benchmark. While frontier models often achieve scores over 90% on synthetic tests, their real-world performance is much lower. In practice, the completion rate for actual tasks is just 24% on the first attempt, and it only reaches 40% after 8 tries. This shows us that the issue isn't a lack of knowledge or reasoning. The real challenge is that frontier models are failing at execution. Intelligence is useless without orchestration. Take a look at the agent spiral. We often think the model is the problem, but the real failure happens in the loop. An agent executes a task, hits a wall, and then starts retrying the same failed logic. After too many steps, it loses context, starts to hallucinate, and eventually forgets the original objective entirely. This proves that the model itself isn't the bottleneck, it's the infrastructure wrapped around it. To build something that actually works, we have to solve for the system, not just the intelligence. While 2025 is being hailed as the year of AI agents, 2026 will be defined by a new discipline: harness engineering. At the core of any system is the model, but raw intelligence isn't enough for the real world. The harness represents the vital infrastructure we build around that model, integrating essential tools, enabling long session memory, and establishing robust systems for error recovery and reliability. To bridge the gap between AI potential and consistent performance, mastering the harness is the defining skill that will set the leaders of 2026 apart. Vercel discovered something counterintuitive. More tools don't always mean better results. Initially, they built a complex architecture of specialized schema and validation tools, but accuracy stalled at 80%. The solution was a radical simplification. By stripping away 80% of these specialized tools and giving the agent basic command line utilities like grep and cat, they achieved the impossible. Accuracy jumped to 100%. Token usage plummeted by 40%, and the system now runs 3.5 times faster. It turns out those complex tools weren't helping. They were just getting in the way. While today's context windows are massive, size alone doesn't guarantee success. As this data shows, AI agent performance stays remarkably consistent until about 50 tool calls, at which point it falls off a cliff. This challenge is so significant that the teams at Meta had to rebuild their agent framework 5 times in just 6 months to address it. The critical takeaway here is that performance doesn't drop because the model forgets. It drops buried under the noise of hundreds of intermediate results. To scale effectively, we have to prevent the signal from getting lost in the noise. We need to stop trying to cram every piece of information into the active context window. Instead, let's treat the file system as external memory. In this workflow, the AI agent writes key information to a persistent file, like Claude.md, and only reads it back when it's actually needed. This keeps the primary context focused and efficient. It's the exact same pattern playing out in your terminal every single day. Look at the landscape of AI coding tools today. OpenAI, Anthropic, and Meta are all taking fundamentally different architectural paths. OpenAI's Codex relies on a complex, layered orchestrator for executive control and recovery. Claude Code takes a minimalist approach, focusing on direct terminal access and the model context protocol. Meanwhile, Meta's Manus project prioritizes reducing and isolating tasks to offload complexity. Yet, despite these unique philosophies, all three have arrived at the exact same insight. It's not just about how powerful the underlying LLM is. The breakthrough realization is this: the harness, the environment, the tools, and the orchestration surrounding the AI matters significantly more than the model itself. In the world of AI, we often find ourselves swimming against the current. Richard Sutton's bitter lesson teaches us that approaches which scale with compute will always outperform hand-engineered knowledge. We see this play out in agent development every day. If your agent feels brittle or keeps breaking, take a hard look at your architecture. As models get smarter, your harness should get simpler. Stop over-engineering the custom logic. and start leveraging the raw power of the model. Step 1. Run the Vercel experiment. This is about radical simplification. Strip down your agent setup and remove those specialized tool pipelines. Instead, provide a simple bash terminal and basic file access, then let the model do the heavy lifting. You'll likely find that the model is much smarter than the rigid tool pipeline you built around it. Step 2 is all about building a reliable memory. By creating a running to-do list in a simple markdown file, we give the agent a persistent source of truth. The core of this workflow is a strict loop. The agent is forced to read the file before taking any action, and then immediately update it once that action is complete. This ensures the agent always knows exactly where it stands in the project lifecycle. It might look simple, but this specific pattern is what the Manus project landed on after 5 complete rewrites to ensure maximum reliability. Now for step 3, we need to shift our focus toward extensibility through MCP and skills. The days of hard-coding individual one-off integrations are over. That approach simply doesn't scale. Instead, we're moving towards standardized protocols like the Model Context Protocol. Think of MCP as a universal bridge. By placing it between our AI model and external resources, whether that's a database, an API, or a search tool, we allow the agent to dynamically pick up the skills it needs in real time. The ultimate goal here is to keep the core harness minimal and let the true power of the system live within these standardized, modular skills. Stop wasting time debating which AI model is better on Reddit. The truth is, the exact same model behaves completely differently depending on its environment. Whether you're working in Claude Code, Cursor, or Codex, your results are dictated by the engineering infrastructure surrounding the model. Don't just pick a model, engineer your harness. Choose carefully, because your output depends on it. Welcome to Imbilla.ai, the premier studio for AI-powered consulting. Our mission is simple: to help you learn, build, and transform in an ever-evolving digital landscape. Whether you are looking to master new technologies, develop custom AI solutions, or fundamentally reshape your business operations, we provide the expertise and tools to turn innovation into impact. Let's lead the future of technology together.